Okay, class, we're going to talk about a slant or nonlinear asymptotes. So we've talked about vertical asymptotes, horizontal asymptotes, and we're going to talk a little bit about slant asymptotes. They're also called oblique sometimes. So f is a rational function, and it's just a generic rational function here in general form. So where you have descending powers here, right? Descending on the top, all the way to the 1, and even a 0 over here. And then we have descending over here. But just like when we talked about the horizontal asymptotes, we have this some constant over some other constant. So this an over bn. But the thing we're focused in on is the degrees, the degree of this polynomial over the degree of this polynomial. And as we've talked about, that's how we define a rational function. So n is the degree of the numerator, m is the degree of the denominator. Now remember, we already have these identities that say that if n is greater than m, it resembles the end behavior of a power function. We've kind of already talked about this. If n is less than, right, what that means. So what if n is less than m? We've talked about those. Those are horizontal asymptotes. But then we have the question of what happens if n is greater than m. So we get these different types of functions. So one of them, if n is greater than m, we end up with this idea, which is really just take these two over each other, right? And that becomes our asymptote. If n is greater than m by 1, so that would be n is equal to m plus 1, we have a slant asymptote. So maybe this is a 3, right? Then this is a 2, right? 2 plus 1 is 3. Or if this is a 5, then this is a 4, right? That's kind of the idea. Basically, if this one's only 1 greater, we create a slant asymptote. So let's look at some of these. First, to find the equation of a slant asymptote. And let me kind of go back here for a second. So when we have a vertical, it's a dashed line somewhere, right? Just say we can't cross that. We've already kind of talked about that. If we have a horizontal, it's going this way, right? Right? And we can't be that. So again, if it's vertical, we can't cross a vertical, horizontal, straight like that. Because we get some value, right? If it's vertical, we just get something here. But what happens when, oops, don't do that. What happens if it's just, see that? I don't like that at all. If it's a slant. So if it's a slant, we're going to get some equation. It's going to be a linear equation. It's going to be of the form y equals mx plus b. To find the equation of a slant or nonlinear asymptote, we divide f of x by the numerator of f of x by the denominator. And that determines the quotient, which is our q of x. And the equation q of x is the equation of the asymptote. Hugely important here, hugely important. A rational function cannot have a horizontal and a slant. It can have horizontal, so it can have the vertical and the horizontal. It can have a horizontal or a vertical and a slant. That's okay. It cannot have cannot have, this is no. You cannot have this and this. That won't work. Will not work. No. Yes and yes. Okay, we cannot have a horizontal and a slant. And the slants aren't always going that direction. It could go whatever direction. But I want to be clear, we can't have both. All right, so here we have a rational function. Wonder why that didn't show. Okay, and we need to figure out what it would be. And the general way we handle these is we just do this division, right? We do this long division. We have x minus 3, and then we have 2x squared minus 8x plus 8. And we're going to do this division. So come on, ink. That's fine. Let's do this in this color. Okay. So what multiplies by x to equal 2x squared? Well, that's just going to be 2x. 2x times x is going to give me 2x squared. 2x times negative 3 is going to give me negative 6x. I'm going to apply the negative, which makes this negative, makes this positive. 2x squared minus 2x, that goes away, it's 0. Negative 8x plus 6x is negative 2x plus 8, just bringing that down. Now, what times x is going to give me negative 2x, and that's minus 2. Now, this times this is going to be minus 2x, and this times this is going to be plus 6. Again, I put in parentheses, apply the negative, makes this a plus, makes this a minus. Negative 2x plus 2x is 0. 8 minus 6 is 2. I don't really care about the remainder. What I do care about is this piece. This piece here. So my q of x is equal to 2x minus 2. And this is my slant asymptote. That is how we determine these, and this is the process. So let's try another one, okay? So here we have another one. Same general idea. I'm going to take these, but I have to add some zeros. So I have a lot of stuff happening. So let's see. So we're going to divide by the x squared plus a 0x minus 9. And this is dividing 3x cubed plus 0x squared plus 0x plus some constant of 0, or some really nothing, but we'll see how this turns out and then we'll know. So now, again, I'm looking, let's go with a different color. Let's do, I don't know, black. Okay. So what times x squared is going to give me 3x cubed is going to be just a 3x. 3x times x squared is 3x cubed. 3x times 0x is 0x squared. And 3x times 9, negative 9, is negative 27x. Again, applying the negative, so that's a negative, this is a negative, this becomes a positive. 3x cubed minus 3x cubed is gone. 0x squared minus 0x squared is gone. That's great. 0x plus 27x is 27x plus 0. Now, there's nothing I can multiply x squared by to get a single x. So this is my remainder here. And this is my q of x. So my slant asymptote is 3x. All right. I hope that helps with the slant asymptotes. And you guys have a wonderful